Hi. Our project is on evaluating the impact of climate change on malaria. So, a brief introduction to malaria, what it is. It's a mosquito-borne disease spread only with mosquitoes, and the mosquitoes are the biological vectors. It's widespread in Africa, Asia, and South America, with a few cases in Europe and Australia. Various symptoms. Symptoms include fever, shivering, headaches, chills, muscle pain, etc. It's caused by parasites. The parasites are Plasmodium falciparum, Plasmodium malariae, Plasmodium vivax, and Plasmodium ovale. What it does, it causes damage to liver and ultimately destroys red blood cells. Parasites have two life cycles, one inside the human liver and the circulatory system, and the other is inside the mosquito's guts. The spreading of malaria, how it's spread. Malaria spreads when a mosquito bites an infected person. The mosquito then becomes infected by the parasite, and then the infected mosquito then bites a non-infected person, and that's how the parasite is spread, and it's a continuous cycle. The connection of global warming to malaria cases. Well, malaria is spread exclusively with mosquitoes, so basically warming of the climate does various things. It increases the geographic distribution of mosquitoes, basically creates favorable habitats, as mosquitoes like warm temperature and a tropical climate, so this causes an increase of favorable habitat. It also alters mosquitoes' behavior. They need to feed more frequently if it's warmer, because at a warmer temperature the digestion rate is faster, so this causes them to feed more frequently, and the more frequently they feed, the more people become infected. And also increased temperature causes an increased exposure period to mosquitoes, because normally cool temperature would wipe them out, but since it's warmer they tend to hang on a bit longer than what they used to. Alright, so socioeconomic impacts of malaria. So also other things that could possibly contribute to increased malaria cases, basically poor drainage of wetlands, poor farming practices, excessive irrigation, and creating still water habitats, lack of access to hospitals, lack of medical resources, that applies to poor countries, lack in urban settings, and lack of clean water bodies, as mosquitoes prefer filthy water to as their habitat. So basically also there are biological impacts of malaria. Insecticide resistance can emerge in mosquitoes, also anti-malarial medication resistance in parasite might emerge. They contribute to increased malaria cases, as you cannot kill the parasites or the insect or the mosquito. Sorry. Human could develop immunity against malaria and reduce number of malaria cases, but this has not been studied exclusively, so it's still a theory out there. Alright, so impact of global warming of malaria distribution. Well, Martin and others, they determined that geographic distribution of malaria parasites increases because of global warming. They compared their reference year with two possible models, BAU and AP. So basically both of these are models. BAU stands for business as usual, and accelerated AP stands for accelerated policy. Both of these approaches emulate a certain level of greenhouse gas emission globally. So, and this is what we find. This is the emergence of the Plasmodium vivax and Plasmodium falciparum on the reference year. So if we notice in the year 2100, under the AP scenario, we'll see more widespread. It's right there, more widespread along there, more widespread in North America. The intensity of red has increased. I don't know if you guys can see that real good, but that's how it is. And also same thing with falciparum. We can see that there's enormous increase right along there. Increase in North America, a little bit more intense down here, and Australia is a bit more intense. We can compare the reds, and we can see that it's more intense. And that's the accelerated process. So basically, business as usual. This thing, this model includes a more increased emission of greenhouse gases, and we will see that up there it's significantly. There's a lot more frequency. There's a lot more Plasmodium falciparum. Australia has increased up here as opposed to the reference here. It's a whole lot thicker, and we can see North America almost nearly covered with Plasmodium falciparum. Same goes for Plasmodium vivax. We can see that North America is completely covered, and up here too, it's increased a lot of falciparum as opposed to 1990, where there's barely any. So that's one of the evidence that they provided. Cancer and others also said that global warming will extend the exposure time to mosquitoes, and they made 3 models, and then they also emulate 3 different levels of greenhouse gas emission, B1 being low emission, A2A medium, and A1F1 being the highest level of greenhouse gas emission. And their model was exclusively for the African continent. And we'll see the exposure time actually increases as we move along. So this is the lowest emission level, medium emission level, highest emission level, and it's the green area becomes significantly larger, and we'll see that it actually becomes large here. The light green becomes large here as opposed to this, where there's still a little break of little green. And so that's basically this. The green color corresponds to the exposure period, and we will see that with the lowest emission, this is the distribution of mosquitoes, like malaria cases. And we will see that as we go along, it gets progressively worse, as opposed to intensity of red increases and the number of red increases. So intensity and number of red increases, and this being the worst case, we see that this island is fully red now. This was not so red here, but it's fully red now. So, and the red is more intense. The color is more intense. So that was their finding. And Abeku and others, they also studied the malaria epidemics in Ethiopia. They also gathered, they actually made graphs, and they compared the malaria cases with increase in minimum temperature, increase in maximum temperature, and rainfall frequency. They also made a side discovery that landscape has an impact on malaria outbreaks, but they concluded topographic features does facilitate or hinder malaria epidemics. But they didn't go too much in details. But as we can see, malaria case incidence anomaly, so this is basically the increase in malaria cases throughout the years. And they found that this graph corresponds to this more than any other graphs that are out there. So basically, which leads them to conclude that increase in minimum temperature will have a big impact on malaria cases. So basically, this is the increase in maximum temperature. They could not find that big of a correlation. They couldn't find that big of a correlation with the years, but that's what they performed tests, and that's what they concluded. Rainfall with malaria cases. They also didn't find any strong evidence, but they did find that rainfall anomaly has a bigger impact than the increase in maximum temperature. But this has the most impact. The increase in minimum temperature has the most impact on malaria cases. So basically, is that it? Are there other factors besides global warming that could contribute to malaria cases? Well, Reeder wrote 2 papers in 2001 and 2008, and he discussed the other possibilities why malaria cases are widespread. In his paper, he explored social and economic factors, and that he believes that they are responsible for the widespread of malaria cases. But his papers are a bit faulty. He only provides theories and examples to prove his point. He does not present any graph, models, or data to back up any of his points. And his lack of scientific evidence makes him less credible than the other 3 scientists I have mentioned earlier on. So this leads me to believe that global warming does have a direct effect on the malaria cases found globally. Because of various reasons, the increase in geographic distribution, making suitable habitats, and increased exposure period to mosquitoes. Socioeconomic factors does have an impact on malaria cases, but it has an indirect impact. Improving social and economic practices can theoretically help us reduce malaria cases as it did in Europe, but this is not to say that global warming is not causing these mosquitoes to have a wider distribution. And also, access to healthcare and medication could drastically reduce malaria cases in Africa. It's a no-brainer, but still, we cannot ignore the fact that global warming is causing these mosquitoes to have a widespread distribution. And that concludes it. Thank you for your time.